Hi, my name's Dave, and I'm going to answer the question, why do things float in space? Why don't they fall out of the sky? Now, we all know things float in space. We see videos all the time of astronauts and how they can't just sit something down on the counter because it's going to float away. Why doesn't gravity seem to work? Now, there's all kinds of ideas about why this is, about why the space station stays up in orbit, why the moon doesn't fall on us. One idea is that gravity doesn't work without air. It's the vacuum that makes things float. Well, that's not true. If you don't believe me, there's some really cool videos about things falling without air that you should check out. Also, if that were true, then there would be gravity inside the space station, and there isn't. There's another idea that the space station and the moon and everything else is just simply too far away from Earth to feel its gravity. Now, it's true that the gravitational pull of something gets weaker the farther away you get from it. But the International Space Station actually isn't that far away. It's only about 250 miles up. Remember that Earth's diameter is almost 8,000 miles. 250 miles is not a whole lot. The International Space Station gets almost the full force of Earth's gravity. So then what is it? Well, actually, it's because of gravity that things orbit. Now, if I drop something, it goes straight down and lands right under where I let go of it, because gravity is pulling straight down on it. Makes sense. If I give it a little nudge to the side, gravity is still pulling straight down, but now it has a little bit of momentum pulling it to the side. So it falls in this arc and lands a little farther away. If I give it a good solid whack, it lands even farther away. If I throw it, it lands way over there. Now, to put it into orbit, I just need to be able to throw it over the horizon. Well, my throwing arm isn't that good, so we'll have to use a thought experiment. Isaac Newton suggested this one when he first described how all this works. Imagine a cannon on the top of a mountain. Now, if the cannon is aimed horizontally and fires, where does the cannonball land? Well, it doesn't go forever. Eventually, it just lands. Well, what happens if they added more gunpowder, fired the cannonball faster? Well, it would get farther away before it landed. What if they fired the cannonball really, really fast? It would start getting around the curvature of the Earth. And this is where it starts to get really interesting. Now, if it fires a cannonball fast enough, what we're going to see is that the cannonball is pulled straight down by gravity, but it's got so much sideways momentum that it follows this arc and falls and kind of misses the ground. So if we rotate the Earth, we see that we're in exactly the same situation we were before. Gravity's pulling straight down, but it's got so much momentum this way that it falls in this arc. And if we keep following this, it just stays up. It's falling the whole time, but it never actually reaches the ground. This cannonball is in a stable orbit. Well, until it hits the cannon. But so why doesn't this work close to the ground? Why does this only work in space? And the answer is, again, close to one of the misconceptions, it's all about air, or more specifically, air resistance. If you've ever stuck your hand out the window of a moving car, you feel air pushing on your hand trying to slow you down. And if you've done that on the freeway, you've felt air resistance at 70 miles an hour or so. And that's a lot of pressure. Keep in mind that to get into a proper orbit, you've got to be going really, really fast. The International Space Station is moving at about 17,000 miles per hour. If they tried that in the air, they'd probably burn up. So space is important because there's no air resistance up there. So as soon as they get up to speed, they can just coast, they can just keep falling, and everything's fine. And that speed is the most important thing. Like I said, the International Space Station isn't that far up. What's important is how fast it's going. That's why spaceships have such huge engines to get them into orbit. The engines don't have to carry them very far, but they have to get them going to an extremely high speed. So when scientists and astronauts use Newton's 3 laws of motion and his law of gravitation to put things in orbit, to put things in space, that's how they're doing it. They're setting it up so that when it falls, it misses the Earth. So, spaceships, the space station, the moon, why do they float in space? Why don't they fall? And the answer is, they are falling. They're just falling fast enough to miss the ground. Interestingly enough, this is also how Earth orbits the sun. We're falling around it. It's a really crazy idea to think that the ground you're standing on is actually falling through space. But don't worry, this orbit is pretty stable. It should hold out for another few billion years at least. If you learned something today, be sure to like the video. If you've got any questions about anything I just said, ask in the comments and I'll see if I can clear anything up. Thanks for watching.